Now, some right triangles have side lengths that are known as Pythagorean triples. The sets of numbers that are combinations of whole numbers that work in the Pythagorean theorem are known as Pythagorean triples. 3, 4, 5 is the most famous of the triples. And so if you can recognize that the sides of the triangles are a triple or a Pythagorean triple or a multiple of one, you won't need a calculator to find the side lengths. You won't have to round to the nearest tenth because these values are whole numbers. So when you have 3, 4, 5, you could also have 6, 8, 10, or 9, 12, 15. You can use that to your advantage to know and use and find missing side lengths. Now, 3, 4, 5 is the most common or most famous Pythagorean triple, but are there any others? So use the list of squares to see if any other triples work. Use this list and see if you can add 2 of these squares together if it would equal a third, since these are the whole numbers that we're squaring to get our values. So some examples, again, we have 3, 4, 5, because again, 9 plus 16 equals 25, 3 squared plus 4 squared equals 5 squared. But we also could have 5, 12, 13, those side lengths. We have 5 squared plus 12 squared equals 13 squared, because 25 plus 144 equals 169. So that's a Pythagorean triple. We have 7, 24, 25, because 7 squared plus 24 squared equals 25 squared. 49 plus 576 equals 625. And we also have 8, 15, and 17. So that's because we would have 8 squared plus 15 squared equals 17 squared, or 64 plus 225 equals 289. So these are side lengths that are whole numbers that work in the Pythagorean theorem. They make right triangles, but they're whole numbers. You don't have to round. You don't have to take the square root using your calculator. And then multiples of these combinations work too. You can multiply all 3 of the numbers by 2, all 3 of the numbers by 3, 4, 5, and that will give you Pythagorean triples as well. So you want to be on the lookout for these combinations, because that will help you solve for missing side lengths in Pythagorean theorem problems.